In this lecture, we are going to see transport layer. First, we are going to start with the responsibilities of transport layer, and then we'll see the protocols, which is TCP and UDP. And then later on, we will see the TCP header and UDP header. Okay, so then we will talk in detail about the TCP. Okay, so let us start with first the basic things, which is the responsibilities of transport layer. So the number one is that transport layer provides end-to-end connectivity. This is something which is mandatory. So any protocol that works at transport layer must provide end-to-end connectivity. Okay, so that means this is provided by both TCP and UDP. Both provides end-to-end connectivity. Second is your segmentation. Segmentation we have discussed about a little bit in when we had discussed the fragmentation also. So the segmentation is provided by TCP but not UDP. The third responsibility is your flow control. Fourth is error control. Fifth is congestion control. And sixth is something which is connection establish and termination. So majorly you can say, the first one is which is end-to-end connectivity that is provided by both TCP and UDP. The rest of all of these responsibilities are optional responsibilities for transport layer and which are all provided by TCP and not provided by UDP. So the responsibility number 2, 3, 4, 5, 6 are not provided by UDP. So here we can say that UDP implements only the first, which is end-to-end connectivity, and TCP provides all of these six responsibilities. So you have seen that end-to-end connectivity we have already seen, I suppose, but if you were to take a look back, so let me see. And before going to discuss the end-to-end connectivity, let me first tell you about the other layers, that is the data link layer provides hope to hope connectivity. We are already know about hope to hope, that is, so this is one hope, second hope, third hope. So hope by hope connectivity that is being provided by data link layer. Then your network layer provide end to end connectivity. Oh, sorry, network layer provide your source to destination connectivity, which is from this source to the destination, whether a packet is being received by the destination or not, that is the responsibility of network layer. And then your transport layer comes, and transport layer provides end-to-end connectivity by mean of end-to-end means we sometimes can say it is process to process connectivity. As we have already discussed that at a host machine, there are many processes which are running at the same time. And when there are multiple processes running at the same machine, then which process to, you know, at the destination machine to which process the packet should be given. That is the responsibility of transport layer. So let us suppose this is the host, and let's say this is connected with some network. There is another router, let's say this is another network, and there are in between multiple routers and multiple network between host and destination. So let's say this is host 2. Okay, this is the source and this is the destination. Sometimes we can say, in case of transport layer, we sometimes say this is the client, and let's say this is the server. Okay, so at any host we have all the 7 layers, और if we talk about TCP/IP protocol, उसके अंदर आपके पास केवल 5 लेयर हैं: फिजिकल, डेटा लिंक, नेटवर्क, ट्रांसपोर्ट एंड एप्लीकेशन. At the application layer we have many processes. So let's say this is the process 1. I name it process 1 P1, P2, P3, P4, and so on. There are many processes running. Let's say the process P1 is running at port number 40, that is running at port number 41, that is running on port number 42, 43. I'm just taking the random just to make you understand. Later on we will talk about the port. Okay. Similarly, at the host 2, which is at the server side, we again have the 5 layers: physical, data link, network, transport and application. Let's say there are also many processes running. This is something, let's say, process at destination, I name it PD1, PD2, PD3, and so on. Again, they have the port number 20, 30, 40, and so on, like this. So the responsibility of data link layer is something from this host to this router, and the responsibility of data link over here, and again from this router to next router, then again from this router to next router, then again this router to the host. That is what the hope to hope connection, and this is something given by data link layer. Then if we talk about network layer, that will deal with from this host to the destination host. That is the responsibility of giving a packet from this host 1 to host 2. That is the responsibility of network layer, that we called as source to destination connectivity. Okay, now as because I have shown you over here, there are n number of processes are running over at H1, and similarly there are n number of processes running at the host 2, H2. So processes generate and consume the data. Okay, and here the transport layer, what it does, whenever the packet received by the server or whenever the packet is received by H2. नाउ यहाँ पे नेटवर्क लेयर तक ये है कि पैकेट आ चुका है. इट इज द रेस्पॉन्सिबिलिटी ऑफ द ट्रांसपोर्ट लेयर एट द डेस्टिनेशन to provide the packet to the appropriate process. That is what we called as the end-to-end connectivity or the process-to-process connectivity. So here you can see from the application layer, the process is giving the data to the transport layer. Okay, many processes are given data to the transport layer. Here transport layer provide the multiplexing and demultiplexing, that is taking the multiple data from the different sources or different processes and combining into them and sending to the network through network layer. Okay, and then again when the data is received by the transport layer of destination, it is again the responsibility of transport layer to give the appropriate data to the concerned processes. Okay, so transport layer provides here multiplexing and demultiplexing. So here you can see the processes actually the processes are those who are actually generating and consume the data. So here at the source point, the processes are actually generating the data, and here at the destination part, the processes are actually consuming the data. Rest of the layer just transfer the data to the process, that is taking the data from the here let's say from P1 and giving the data to the let's say PD1. Okay, so that is the responsibility of your transport layer. Okay, so transport layer we can write over here, but it is between the processes. Okay, that is let's say P1, P2, P3 and so on. That is the transport layer, and giving it to PD1, PD2, PD3 and so on. Okay, like this. So that is the responsibility of transport layer, and that is what we mean by end-to-end connectivity. Now here I termed the source and destination as client and server. So client is something, a machine which generate the request. Okay, or in the case of transport layer we can say it is something who is sending the data, and the server is something who is actually replying. So client is generating a request and server which is replying. Okay, so server is nothing but a software to serve multiple clients. So let's say this is the server. So there is not only the host, or there is not only the single client that is connecting to this server, but there are multiple there are other clients also who are trying to contact the server, or who are making connection to this server. So server is nothing but a software to serve multiple clients that run on a special hardware called as server. Okay, so that is nothing but a machine जो कि एक साथ multiple clients को आपको serve कर सकती है. ओके, सो यहाँ पे हम इस चीज़ को डिस्कस कर चुके हैं कि ये एंड टू एंड कनेक्टिविटी ट्रांसपोर्ट लेयर आपका प्रोवाइड करता है. Now, there are few things that I want to quote here. Number one is, you can see over here कि यहाँ पे जो प्रोसेसेस हैं, तो जितने भी प्रोसेसेस हैं वो जो प्रोसेस है वो किसी ना किसी पोर्ट पे, किसी एक फिक्स पोर्ट नंबर पे रन कर रहे होते हैं. ओके, सो वी विल सी लेटर कि पोर्ट नंबर आपके पास कितने होते हैं, और वो कौन से पोर्ट नंबर किसके लिए असाइन होते हैं, इस तरह की बात हम आगे करेंगे. बट द थिंग इज टू फॉर नाउ इट इज नेसेसरी टू नो दैट एवरी प्रोसेस इज रनिंग ओवर ए पोर्ट नंबर, एंड दैट पोर्ट नंबर इज फिक्स. Port number is nothing but a 16-bit number. Okay, so now we will see there are two protocols which are running the TCP and UDP. They also have the field in their header called as port number. One is source port number, another one is destination port number. There is one thing that I want to mark here, you have to note first. We will talk about it later also, but for now you can note here that the source port number is a dynamic port, while the destination port is fixed port. Okay, so that means when the source port number is dynamic and the destination port number is fixed, okay, that means the data is moving from client to server. First of all, there is one thing that TCP uses full duplex communication. So full duplex में आपका क्या होता है? The data can be moved, from source to destination, or you can say client to server, either this way or this way. So both ways, the data is going to transfer at the same time. That is what we mean by full duplex communication. So as because the TCP uses the full duplex communication, that means sometime the source can send the data to destination, and also destination can send the data to source, or in other words, client can send the data to server and server can send the data to client. Now, how can we know in which direction the data is going to flow is something from here. So the source port number is a dynamic port. So whenever the source port number is dynamic and there is fixed source number at the server side, that means the data is moving from client to server. And if source port number is fixed, and destination port is dynamic, then we will say that data is moving from, sorry, data is moving from server to client. Getting it? Okay, now I was talking about that port number is a 16-bit number. Okay, and hence we can generate 0 to 2 raised to power 16 minus 1. Okay, this much number of hosts, 0 to, in total there are total 2 raised to power 16 number of hosts, 2 raised to power 16 number of ports. Okay, and we can have the number 0 to 2 raised to power 16 minus 1. That is, we can have for the port numbers, we can have 0 to 2 raised to power 16 minus 1 is nothing but 65535. Okay, so in total we have 65536 ports in total. Okay, which can be numbered from 0 to 65535. Okay, later on we will see the distribution of how the what kind of port and what are the ranges, different ranges. Okay, that we are going to see. So broadly, if we look at the transport layer header, so there would be, let's say this is the message, and this would be source port number, and this would be destination port number. That is, when I'm talking to transport layer header, that by I mean कि यहाँ पे TCP header और UDP header दोनों में ही आपका ये common structure जो है वो रहने वाला है. In detail we will see later कि TCP header किस तरह का होगा और UDP header किस तरह का होगा. ठीक है, अभी just for the purpose of understanding, मैं केवल यही लेके चल रहा हूँ. So let's say at a host 1, and let's say in between the routers and there are other routers, and that let's say this is host 2. So at host 1 there are 5 layers: application layer, transport layer, network layer, data link layer, and physical layer. So at application layer there are many processes, as we have discussed. Let's say this is process 1, process 2, process 3, process 4, and so on. Port number was, let's say, 40, 41. Let's say this is 20, 21. So when the application layer is going to this data or message to the transport layer, what the transport layer will do, transport layer will add over this message, transport layer will add the source port number and destination port number. So let's say this process has given the data to transport layer. So the source port address is 40, source port number is 40, and let's say it is destined to the port. Let me first draw the host side, receiver side, physical layer, data link layer, network layer, transport layer, and application layer, and many processes. Let's say this is PD1, 2, and so on. Let's say this port number was 20, 20, let's say 30, 35, or 40, and so on. Let's say this process with which is running at port number 40 at the client side want to send the data to host 2 and to the process with port number 20. So the destination port number is going to be set as 20. Then this is going to be given to network layer, and over this payload complete will be given to network layer, and this would be the you know network layer is going to add the source IP address and destination IP address. Then this packet is given to the data link layer, and the data link layer will add one tail and will add header. In between there is payload from the network layer, and which is this. And data link layer will add the MAC addresses, that is source MAC address and destination MAC address. Okay. And at the receiver end, when this data is going to travel through the network, when it is received by the host 2 or receiver, डेटा लिंक लेयर के जो हेडर और टेल हैं वो आपके यहाँ की डेटा लिंक लेयर will read it out and then make them remove if it is destined to the same host. Okay. Then network layer उसके source IP and network IP अपना, that means अपना header को यहाँ से remove करेगी, and it will give the payload to transport layer. At transport layer, this is going to be received, which is the message, and destination port number as 20, source port number as 40. Now data link layer is going to remove this header, and will give the packet or will give this message to the application layer, and in the application layer to the particular process which is what the destination port number is. So at the destination port number, which is 20, so PD1 is the process which is running at the port 20, so it is going to give the message to this process. So that is what the process of how the transport layer maintain end-to-end connectivity. Now we will see the two protocols which are being running over the transport layer. So protocols at transport layer. Number one is TCP, second is UDP. This is transmission control protocol and this is user datagram protocol. This TCP protocol is basically connection oriented. कनेक्शन ओरिएंटेड से यहाँ मेरा मतलब है whenever a data or message is being transmitted with the TCP protocol, before sending the data a connection should be made. यहाँ पे कनेक्शन बनाने से मतलब ये है कि रिसोर्सेज आर बीइंग रिजर्व्ड. ओके, सो कनेक्शन ओरिएंटेड का मतलब है रिसोर्सेज आर बीइंग रिजर्व्ड at the other side. सो देर इज नो वायर्ड कनेक्शन और टाइप ऑफ थिंग, कि ऐसा नहीं है कि कनेक्शन से मतलब है कि दोनों के बीच में एक वायर लगा दिया जाएगा या और कुछ और. ठीक है, कनेक्शन ओरिएंटेड से मतलब है कि वेन एवर द डेटा इज बिंग सेंड थ्रू टीसीपी प्रोटोकॉल the resources are being reserved at the other end. For example, let's say buffer is reserved, okay, the CPU is reserved, okay. So likewise we will see in detail when we will discuss TCP, okay. Similarly, if we talk about the UDP is connectionless protocol. That means no reservation is being done before sending the actual data, okay. So now we can see over here that TCP is more complex as compared to UDP, and hence TCP is slow as compared to UDP. So if we talk about the speed, so we can say TCP is more complex than UDP, and hence TCP is slower than UDP. Okay. Now we all know, we will see. We have already seen, I think, this part, that how the protocols are running. So let's say this is the IP protocol which is running on the network layer. This is the data link layer. Oh, sorry, this is the transport layer. And this is the data link layer. Okay. So just below to IP, we have ARP and RARP. Just above it, IP protocol, we have ICMP or IGMP, and in the transport layer we have TCP or UDP, and above it we have the application layer, below it we have this data link layer, and then the physical layer. So whether an application uses TCP or UDP, it depends on the requirement. That is a question, that where when we should use TCP and when we should use UDP. Okay, so that is a question. Now I can say it TCP sorry, UDP is used number one if error or flow control is not required, because we have already seen when we were discussing the responsibility of transport layer. So we have seen that UDP does not provide error control and flow control mechanisms. So let us suppose these all error control and flow control are being already implemented in application layer. So let's say these are implemented in application layer. कौन सी ऐसी एप्लीकेशन होगी? फॉर एग्जांपल वी हैव द एप्लीकेशन लाइक TFTP, okay, trivial file transfer protocol. Another kind of applications where speed is important as compared to reliability. Or we can say we have sometime we have one request and one reply kind of application. वहाँ पे भी आपकी क्या है, UDP यूज होगी. उस केस में हमें प्रॉपर कनेक्शन एस्टेब्लिश करने की जरूरत नहीं, कनेक्शन टर्मिनेट करने की जरूरत नहीं है, बिकॉज वी वांट टू सेंड फ्यू डेटा ओनली, और उस केस में आप UDP का यूज़ करेंगे. इस तरह की कुछ एप्लीकेशन के एग्जांपल में आप आपके DHCP, सॉरी DNS हो गया, आपका आपका बूट भी हो गया. ओके, सो इस तरह की एप्लीकेशन. सो इस तरह की एप्लीकेशन में आप UDP का यूज़ करेंगे. और इन अदर वर्ड वी कैन से दैट UDP इज यूज्ड where no reliability is required or minimal reliability, when we have small packets to transfer, when we have no requirement of error control and flow control. Okay, so because of this, these are something overhead, and that TCP does not provide. Sorry, TCP provides actually, and UDP does not provide them. And why UDP does not provide them? UDP क्योंकि क्या है कि स्पीड को ज़्यादा फोकस करता है. ओके, सो अगर हम ये सब ओवरहेड भी इंक्लूड करेंगे, सो स्पीड इज गोइंग टू अफेक्ट. सो दैट इज़ वाई UDP की आपकी कुछ जो भी आपकी एप्लीकेशंस होंगी, वो जो ऐसी एप्लीकेशन जिनमें आपकी इस तरह की रिक्वायरमेंट नहीं है आपकी, तो आप वहाँ पे UDP यूज़ करेंगे. अदरवाइज यू आर गोइंग टू यूज़ TCP. Okay, now further we are going to see the header structure of TCP, and later on we will see the header structure of UDP.